Session. So myself is Ehtisham Raza. I'm working as a AI strategy lead at Hazen Technologies and also working as a data trainer and coach at Data Tech On. So today I'm going to talk about how you guys can develop an AI system which can not only understand your prompt but can also understand your context and your intention, what you're trying to achieve through your large language model. So without waste of our time, let me start sharing my screen. Today we're going to have a all technical discussion on this one. If you guys are preparing for your final year project, if you have creating any your research project, this topic is going to help you how you guys can feed the information to your large language model, so which can be more contextual and more personalized about your data set. So just confirm me, guys, can you hear me very well so I can start sharing my screen?
Yeah, we can hear you, Russell.
Okay, thank you. Okay. So building an AI system that can understand the context, what is meant by context. Let's say we are using a chat GPT, we are using Gemini. You enter any prompt, you enter a very large text of prompt, and that model, that large language model, has the capability to understand what you're trying to generate. If you are creating an email, so what you are trying to say to that large language model, it has the capability to understand the context. So context, understanding of context is really important for these large language models. If your models are not able, cannot understand your context, you may not be able to do well. Just assume if you're trying to create a you're trying to write a blog about the machine learning, but you enter a prompt, it start giving a blog related to the software engineering. So that blog is not going to be useful for you. So to make sure what you're trying to give command to your large language model, it should understand that totally depend on the contextual understanding. So we're going to see the backend, how the things working in the backend, how these things are evaluated, how your contextual understanding is built in this large language model. I think someone is trying to join. Let me allow those people as well. So admit. Okay. So my introduction, as Ali has already introduced myself, let me introduce myself again. So I'm working as a AI strategy lead. I have around 5+ years of experience in solving machine learning problems, deep learning problems, generative AI problems using different type of domains knowledge. I'm working as a trainer as well at Data TechCon. So that's all about myself. If you guys have any query, if you guys want to connect with me, you can easily connect with me over the LinkedIn. I'm always available on LinkedIn. I like to address the queries of the people. I like to assist people of my domain. So if you guys have any query, if you need any question, if you need any guidance, I'm always available. Today's agenda, we're going to talk about the introduction to large language models. We're going to see what are large language models. Then we'll see how prompt engineering works. Then we'll talk about in detail the attention mechanism. Then we'll talk about context aware AI. What is meant by this? After understanding all these things, we'll be able to just simply connect how these things are interconnected with each other. So, without any waste of time, let's see. As we have seen these days, everyone is talking about Gen AI, and this domain is totally in demand. If you have seen the problems of machine learning is totally changed now. There was a time when people used to create the classification models, they used to create regression models, but now the problem is really big. Someone is trying to create a assistant which can assist your customer. Someone is trying to create a speech recognition model which can identify who is talking to me, is it a person, and it can also generate a voice based model that can create a cloning of the inhuman's voice, and it can just simply assist. So these are all applications of the generative AI. What is meant by generative AI? Generative AI refers to the set of artificial intelligence methodologies that can produce novel content that resembles the training data they were exposed to. So the content could be anything spanning from synthesizing context, generating a code, realistic imaging, anything. So generative AI is a specialized form of artificial intelligence. It comes under the umbrella of artificial intelligence, which is trained on large amount of training data and after training it has the capability to create a novel and newer content which maybe that model has seen or maybe not. So generative AI is a model that is trained on large amount of data set. It can be unstructured. So because when you are feeding a very large amount of data set, it is really difficult for you to make your data structure. So that's why it's called unstructured. It could be semi-structured as well, but you can't assume your model going to have the structured data set. After having this input data, the model goes and learn from all the parameters, from all the features of the data set, and after training, it has the capability to create a new output. That could be a new content. If you're trying to generate any images, if you're trying to generate anything, it has the capability it can generate. The motivation of generative AI. Why do we need the generative AI? Why the traditional machine learning and deep learning models are not useful these days for us? Just like assume you're training a convolution neural network where you're trying to feed a we are trying to solve a multi-class problem. Thus, limitation of this convolution neural network, it cannot go beyond to certain extent. It cannot understand the contextual feature of the object which you're trying to achieve, and it cannot understand dependencies in your data set. So this is the limitation with the CNN. And similarly, if you guys have work on the recurrent neural network, do you guys have any idea about recurrent neural network? Just you guys can unmute your mic and let me know what is meant by recurrent neural network. If you guys don't know about this, no problem at all. I'm going to explain about this, but if you guys know, anyone can just simply tell us what is meant by recurrent neural network. Seems like you guys are not familiar with this one. So recurrent neural network is a type of deep learning neural network which has the capability to understand the contextual data set, but this algorithm has the very limitations. It cannot understand the dependencies in your data. Just assume in your language, in your Urdu language, not every word is connected with each other. Same like in English, every word is connected with each other. If you just simply remove a single word, the meaning of your whole sentence will be changed. So sequential understanding of the models is really important so you can perform your task. So there was a time when recurrent neural network was used for the translate in use was used in the translation applications, but now these days this problem is solved by using the generative AI model. The problem with this algorithm was this model was not able to understand the longer dependency due to the ability to process the data sequentially. So sequential data was a bigger problem for this model. It was able to process the data set which was in a shorter length, but when the data set was exceeded to a certain length, it was not able to work well. So that this model always uh, struggle with the problem of vanishing gradient. So there were many problems happened in the past. Those problems was making really a bad luck for those models. They were not able to work. So now we have the generative AI models. They can easily process not only the longer sequential data, but it can also work like where the CNN models and the RNN models can be just like if you combine these two models in a single model, in a single generative AI model, this we can easily get them both features in a single model. Generative pre-trained transformer, how we got the motivation of the generative pre-trained transformer GPT, which is also called a new architecture called transformers, is proposed by the scientists from Google, which avoids the recurrent corrections altogether by relying on the attention mechanism. So just in 2018, uh, Google researcher just launched a transformer architecture. That architecture totally changed the dynamics of the AI industry. Before this, people used to rely on the deep learning model. They were not relying on the attention mechanism. They introduced a mechanism of the attention. What was meant by the attention mechanism? Just like if you go to, if you're, let's say, if you're reading a news article has many news related to different topics, sports, weather, politics. You are not interested to pay attention to to the weather news. Even you are not interested to pay attention to the politics, but you are interested to the sports. As you simply see the news related to the sports, automatically your brain will trigger you and will start reading about the sports. Similarly, attention mechanism give the ability to your deep learning, to your generative AI model to pay attention where you need to pay the attention. Let's say you're trying to solve a problem related to a classification and you're performing a classification of animals. If any other object is shown inside in front of your model, it won't pay attention. Only it will pay attention which is trying, this is the problem it's trying to solve. Because whenever you pass a big amount of data, your model has the problem. Maybe it could get biased, it could have a problem with the pay attention to any single object. But using the attention mechanism, it allows you to pay attention to only those features which are really important for you to make a prediction. Let's say I'm trying to make a problem statement. I'm just trying to solve a problem where I have to detect a disease of cancer. Maybe I can have many diseases, but my most important disease for my model to identify that cancer, I can show many images, I can show many MRI images of cancer to my machine learning model. It will automatically goes out among many other images. It will go out and it will find how does the cancer tumor looks like. It will go, it will find out, it will see, okay, observe the tumor, how does the tumor look like, the size of the tumor, what is the dimension of the tumors, and out of all the box, it will be able to digest all the related information of the tumor. So this is how the intention mechanism works like. It doesn't pay attention which you're not trying to do, it is only pay attention what you're trying to do. So out of when you're passing large amount of data, instead of wasting time on going over all the data set, it has that capability to pay attention to only where I have to look at. So this is the attention mechanism which was devised from the Google researchers, which basically change the total dynamics how to pay attention to your problem statement you're trying to solve among the bigger data set. Introduction to large language models. You guys may be already familiar with large language model. What is meant by LLM? LLM is a large language model. It is trained on vast amount of data set to generate a human-like test. Just like GPT we are using these days to solve our problem statement. Some people may be using the GPT to solve their assignments. Some are using to write their email. Some are using to create their proposals. Anything you are doing with the GPT is helping us. It is a large language model. Gemini is also a large language model. Even DeepSeek is also a large language model. Those models which has the capability to generate a new text, a human-like text, for us it is called as large language model. Using deep learning algorithm transformers attention mechanism to process language, continuously improve through fine-tuning and reinforcement learning. This is how the LLM works. Can you guys tell me what is meant by fine-tuning? Oh my god, many people are in the waiting list. Guys, can you tell me what is meant by fine-tuning? Or should I call anyone?
Tuning, excuse me, sir. Assalamu alaikum.
Yes, well, Sam. Yes,
Fine
Khizar.
tuning, fine tuning means to train your LLM or
Mm-hmm.
any AI model according to your own data set.
Yes, fine tuning means you are improving the learning of the model on your own data set. I have a question, guys. Can we do training of large language model? Can we train our large language model from scratch? Is it possible?
No,
Why? Wazir?
uh, because it's required a lot of data and
Required lot
GPUs
of
like
data, lot of configuration, lot of computational power.
mm,
If you just
yes,
simply
yes.
pick a model, a very, you can say normal size model, a BERT is a large language model, which was the very first large language model generated by the Google. Even if you try to train that model is basically trained on all the data set of the, yes, for us, you can ask unmute yourself. If you try to train the model on that model is trained on all the data set which is available on the Wikipedia. So just assume how big is the Wikipedia and that model is trained on all the data set. First of all, if you try to train a large language model of simple bird, you cannot do it because you will need a lot of data set. Without providing the lot of data set, you can't expect your model is going to perform really well. And second, if you have to train the model, you need a lot of resources, you need very high computational power. And what's the third thing? These are the two things. What's the third thing? We train, if you guys are familiar with the machine learning, you guys can easily answer this. Does anyone know? The third thing is the hyperparameters. In machine learning, when we, if you guys are familiar with the decision tree, decision tree has many different hyperparameters. Setting the right number of parameters, you will be able to get the good accuracy. But as you guys know, you all the time you're not, you don't know which is the right parameter I have to set. You apply different type of techniques. After doing multiple iteration, you always ended up with a good number of hyperparameters. Third thing is the hyperparameters. Choice of the right parameters is really important to get a good accuracy of your model. If you are not able to set the right parameter for your large language model during the training, you can't expect a good accuracy of the model. So these are the three factors which makes really difficult for you to train the model from scratch. But in deep learning, in gen AI, both of the applications, they have the capability of fine tuning. And second thing is transfer learning. If you have the smaller data set, and you these model has the capability to learn with a very smaller data set, and after learning they can easily adjust on your task which you're trying to solve. I When I was working in one of my project at my job, I had a data set that had around only 130 rows. But that data set was a textual data set. I just simply fine tuned this BERT model, and my model was able to give me a very good accuracy. And I was trying to solve a model. I was trying to solve a problem statement which can easily, which has to do the classification of 8 different classes. So just assume these large language models can be easily fine tuned on your data set, and after doing the fine tuning, you can just simply get your job done instead of going back and training the large language model from scratch. Why they are important? It can easily automate the tasks that previously required human effort. Just take an example of Gemini. You have to write an email, even you have to write a blog. You have a website, you are like daily blogging, you like to post a blog every day. Now you don't have to spend a time in writing a blog. Just simply type a command and it can just simply start writing a blog for you. Just in seconds, your blog will be ready. Handle activities like formatting presentations. Obviously, you don't have to do the formatting presentation. Customer support and ad creation. Customer support, you have to assist your customer, you have to analyze the queries of your customers, you have to create a post, you have to create an ad for your Facebook page, anything you want to do. Execute tasks more accurately. Obviously, you have to generate a code. Just in few seconds, it can just simply create a code for you efficiently at lower cost. Sometimes some many open source large language models even don't charge you. But let's say if you're using a chat GPT, it will charge you very less, but it will be paying you what you are paying for it. Free up human time for high level decision making and management. Obviously, it is freeing humans from higher level management, decision taking, and it management. You don't have to spend time in doing those tasks which requires humans intervention, and you can pay attention to any other task where human decision making is really involved. So these are so important. How does LLM work? Can anyone tell me how you enter a prompt, how the prompt is processed in your large language model, and how it come up with a right content for you? How does LLM work?
It has vectors, and whenever we enter a word, it predicts what's going to come next. And
Mhm.
based on those vectors, which have a lot of dimensions, it thinks and then it generates.
Yes, yes, yes. Khizr, can you just elaborate it, because you have mentioned about the vectors? Can you just explain what are vectors?
So vectors are like matrices. Basically, there's plane, there's 2D, and then there's 3D. Humans
Okay.
can visualize third dimension as well, but
Yes,
computers can visualize fourth, fifth, sixth, and then up to 1200 or 1500. Like
it can be any number
mostly
of them.
generative models. Yes,
Yes.
mostly like generative models, they work in 1200 or 1500 something dimensions. So when you predict so the thing is from it will go here, the next word will be here or here. So there are multiple directions like that. So that's how it predicts.
I have a question. Why do we need vectors?
So because you can't store it linearly. If you store it linearly, then the searching time would be longer.
Okay, okay. Very good. Very well explained. I really like this explanation. Let me add on top of this as well. We have learned since our childhood, machines only understand the language of 0 and 1. Machine don't understand what you are trying to do. What, let's say, whatever we do, it doesn't understand the human language. The language of the machine is 0 and 1. Same with these models. These models, machine learning models, deep learning models, Gen AI models, only understand the language of the numbers. So first, when you enter a prompt in your chat GPT, how does the chat GPT works? It converts your prompt into the tokens. What is meant by tokens? Let's say, hello, can you write a blog for me? So hello will be a separate token, will be a separate token, can you will be a separate token. Every word will be chunked into a token. Token is just a whole sentence will be divided into the words, so it will digest one by one. It looks like very clear, it looks like very simple, but the things how it works on the back end is, first it applies the tokenization. So in the result of tokenization you will end up with the chunks of your words. Then it will do the mapping. As this Khizer, yes, Khizer has just told about the mapping is, those tokenized words will get converted into the vectors. Vectors are just nothing, just a representation of textual word into the numbers. So hello will be a specific word in mapping, can will be a specific. So each word have a defined in the vocabulary of the these models have specific number that will be converted into the vectors, and those vectors will be further feed to our model, because models we have already mentioned, they understand only the language of 0 and 1. So to make your model to learn what you are trying to do, we need these vectors, we need this matrices in the form of embeddings. So embeddings, once we got the embeddings, then these embeddings will be further passed to the deep neural network, deep layers, where the multiple calculations are applying, where the normalizations will apply, where the attention mechanism will be applied. So contextualization, I'm trying to write, can you write a blog about the machine learning? So what I'm trying to say, what is my context is, I need a blog, when which topic I need a blog about the machine learning. So this is my context, which is I'm trying to achieve, which is I'm trying to train, I'm trying to give, this is my command, I have to get this blog from my deep learning model. So my contextualization will be working on the machine learning model. It will pay attention. Okay, my user is trying to get a blog related to the machine learning. So it will pay attention. This is my contextualization. I am setting a context of my GPT. Once the context is set, again it will go further. It will apply the auto-regressive manner. It will start generating a words and it will give me the output. So this is a very simple. I am not going in very depth because this is our day first. In our upcoming sessions, we'll just simply do the diagnosis. We'll just simply go on the back end. We'll understand what is black box, but how the things are working behind this. But I can assume you most of the students are joining from uh, uh, they don't have much idea about this thing, so I'm just keeping on the low level so you guys can understand, but we should understand how things are working, so we're going to cover that. So we're going to have the contextualization. The context is set of our model. Our model will be understanding, okay, my user is trying to generate a blog related to the machine learning, so the context will be set here. And in the last phase the output will be generated. So in the four steps your large language model work. So first it comes the tokenization, because it has to process the information in the form of, in the sequential way. So it will do the tokenization, so every sentence will be chunked into the words. Then we'll have the mapping will convert the text into the embeddings will be further passed to the contextual window. That contextual window will be generating the content, the setting the content, the context, and it start with generating the output. So this is how the LLM work. What is meant by transformers? So LLM is basically backed by transformers. If you are talking about a large language model, just assume it is backed by transformers. Without transformers, your GPT is nothing. Before transformers, we had the very simple model, deep learning model. But after transformers, we have a very complex models which can easily understand, which can easily process the sequential data where the simple deep learning models cannot process, which has the capability of the attention mechanism, which has the capability of the encoding, which can easily process your long sequential range of input data in just a single seconds. So transformers are deep learning models designed for handling sequential data. What is meant by sequential data? Just like you are entering a prompt, that is a sequence. You are entering a sequence. Sometimes we copy the whole code, sometimes we are getting code error in our code. We just simply copy the whole code and also the error, and we just simply give it to the chat gpt. Chat gpt process this sequential data, and after processing the sequential data, it finds out an error. How it is able to finds out an error and it's able to give us the code with error free? Because it has the capability of the attention mechanism, that attention mechanism making it this transformers based algorithm that much efficient to fix that code. If you don't have this attention mechanism, when you copy the whole code, you also copy the error, and also you give, can you please fix this error? So now the attention of this transformers model is to fix this error. You are giving a command, can you fix this error? How it is able to pay attention? Because you are feeding it, can you fix this error? So now it is paying attention to that error, and it will come up with a solution which can be error, which will be error free. So the components of the transformers which makes it unique from deep learning model: self attention. Self attention means enable to weight importance, give importance to each input sequence. Just like we listen, our parents all the time give us advices, we only pay attention to those advices which we really like, and which we don't, those we don't like, we just simply ignore those. So we are very good, we only keep those things in our mind which we like, and with those things which we don't like, we just simply ignore this thing. So self attention capability, the mechanism is same like that. It pays importance to that each sequence, that important sequence which is going to be useful in solving a problem. So in terms of in example of solving a problem of error in my code, my attention should be in fixing the error. So my model, my deep learning, my transformer should be helping in me to assisting that error. And second is the positional encoding. When you apply the tokenization and when you apply the vector, when you convert these tokens into the vectors, sometimes the problem get, you can have a problem when, because you are converting your textual data to the numbers. So to make sure, some, as you know, in English understanding, if you just simply change the arrangement of words, the meaning of your line will be totally changed. So to make sure the model easily understand what you are trying to explain, we apply the position encoding. Positional encoding basically makes sure to keep the right track of the words. It should not be changed when you're converting from text to the words, from text to number. So make sure, to make sure the model is accept and understanding the same thing which you are trying to which you are trying to explain him, the positional encoding is applied. So transformers has these two capabilities of the self attention and the positional encoding, which makes it unique from the other deep learning model which they don't have. Advantages, what are the advantages? The advantages are really high as compared to the deep learning models. It can easily go in the parallel processing. It can handle the sequential data in parallel rather than step by step. So if you are trying to create an application, AI based application, which should understand your contextual understanding as well, and it should generate your data set, it should process your data set in a parallel, you should go for the transformers based algorithm, which can easily understand your data set based on the contextual understanding, and can also process the data in your parallel. Handling long range dependency, capturing the relationship between distant words in solving problems, just like traditional RNA algorithms, it can do really well. Not only these transformers are limited to you can say the contextual, only the textual problem, it can go to the visual problems as well. So vision transformers are also available. You can apply to the image processing, just like you're trying to solve you have an image, you give the chat to the chat gpt and start, and you ask what's going on in this image. So image, you start getting the, you can say the captioning of for that image. So the, this is because of the vision transformer as well. So we don't have only the transformer for the textual understanding, we have the transformer for the vision as well. So those this transformer based application can easily go and start giving the caption for your image. How does the architecture of the transformers looks like? You have the two parts of the transformer. First is the encoder part, and second is the decoder part. So encoder part is basically to encode all your input sequence, and in the decoder side it goes and just simply start generating the output. Some of the large language models only use the encoder part, just like if you are using a BERT model, it is only encoder based algorithm. it only use the encoder part. Encoder base is used only for the classification problem, but decoder part is used for the text generation. So some algorithms use both parts, encoder and decoder. Some algorithms use only the decoder, some algorithms use only the encoder. Can you guys tell me, ChatGPT use encoder decoder both, or use only in decoder? Can anyone tell me? I need, what is the transformer architecture behind the ChatGPT? Yes, I'll share the slides after this session. Fraser, do you know which transformer architecture is used behind the ChatGPT, Gemini, and DeepSeek? All these three platforms use the same architecture of transformer. Guys, do you know? If you guys don't know, just let me know in the chat, so I'll go in more detail and I'll explore that part as well. Silence, quick silence.
Sir, maybe both because it's a text generating model. That's why I
Okay,
think.
no, it use only the decoder part. So in ChatGPT, Gemini, DeepSeek, all the platforms which take your prompt and generate the text, that use only the decoder part. That is a very core concept. You must just keep this in your mind. Why do we need only the decoder part? Because we are just simply trying to generate a text. We are not trying to. We are not performing from any, you can say, classification task. When you need any classification task, you need an encoder part. And when do we need both parts? Let's say you are performing a task related to the text translation. You have a English text, you have to convert into the Arabic. Then you will need both encoder and decoder. So encoder will be encoding your all the information and the input data, and on the decoder side you will be having the other language as well. But in GPT we only need the text to process, and based on its learning it just have to generate a text. So it only use the decoder part. And how it process the data set, how it process the content which you are trying to generate, it process in an auto regressive manner. It generates a text by text. As you guys seen, when chat gpt start typing the output for you, you get the words by word. It's, although it's very fast, but it process in the form of auto-regressive manner. So you guys can keep this in your mind. This is how you can say, it's also an interview question as well. GPT is only using the decoder part, and many classification algorithms, large language models, which are out there, which takes a bunch of textual input, and you just have to perform a classification from which class belongs to this. Let's say you're trying to perform a sentiment analysis, but your input data set is very big. You have the around thousands, 2000, 3000 words. So you are going to use the encoder model, which is going to process all the input textual data. And after performing all the processing on all the input textual data, it's going to give you the output. Okay, this belongs to this class. So that's use the encoder part only. So this is the whole architecture of the transformers. We have the embedding model. You have the input sequence. That input sequence will directly go into the embeddings model. Embeddings are, as I just told you, are textual, numerical representation of your textual data. Then we have the positional encoding. Before further passing your data to your further multi-head attention and further pre-processing layers, we have the positional encoding to make sure the data you are passing to your further layer won't be displaced, won't the arrangement won't be misplaced. So make sure the data you're passing, trying to say show to your model, is going to be same which you are trying to in the numbers. Then you have a multi-head attention. Multi-head attention, just nothing. When you combine multiple self attentions together, that is called multi-head attention. Sometimes single self attention won't be enough for your problem which you're trying to solve. So you just simply apply the multi is parallel self attentions, so your model will be more accurate. You will have a more contextual understanding of your model. Then you have the normalization layers. Normalizations layer, as you guys do, if you are done, if you are use the machine learning models, you do the normalizations. You have a bigger range of input, you pre-process and you bring it to the small values. So you apply the normalization layers On top of that, so when you're processing your data set, it should be normalized. Then you have MLPs, multi-layer processings. Then further you have normalization, and further this data will be passed to the decoder if it is a decoder and encoder combination. Otherwise, if it is encoder based, it will be the end of this architecture. But if you are going with both sides, then you will have again further positional encoding. Then you will have multi-head attentions, and maybe you can have the cross attentions as well, according to the use case which you're trying to solve. Then in the last you will have a normalization layer, and then you will have a softmax layer will be detecting the output for you. So this is how the transformer architecture. I am not going in too much detail. You guys can expect this too much detail in our upcoming sessions. Just to get overview, this is how the architecture looks like. So we have the encoder where the input is encoded as its name is telling, information is going to be encoded. On the other side, the information will be decoded and the output will be generated here. You can use any single part as well based on your use case. Attention idea. Why do we need attention? Allowing the decoder to access entire encoded input sequence. Why do we need attention? Because not every input prompt, not every not whole prompt is useful us. Only specific word in the prompt is going to define what we are trying to solve. So how this attention mechanism is applied? So attention mechanism is applied through three mechanism. Q key value. So your input will be directly passed into the query key value that will be processing your whole prompt, and it based on this processing it will identify on which part I have to pay attention. Okay, I have got very big input, but in the very big input my only task is to fix the code. Okay, so I am trying to solve the fix the code. This is my attention where I have to pay attention. So this attention will be calculated based on the query key value calculation that is applied to the the dot product. That is all the mathematical calculation. Based on this, you have to identify what I'm trying to solve. So attention mechanism is basically applied on your prompt. It prioritize what I have to do on which section of your input I have to pay attention. So based on that, I have to take my step. How humans pay attention to the relevant information, just like this large language models do the same. Is this attention mechanism is basically got the modification from the human's attention level mechanism. Imagine you are reading a news article about the football. While you are reading, you're going to focus on key information. You skip unimportant details. You have a newspaper in your hand. You're not going to pay attention to the weather condition. You're not going to pay attention to the politics. You're only fan of football, so you're going to prioritize the relevant section where you have the information related to the football. And specifically, among many news related to the football, you are a Madrid fan. Then you're going to pay attention how much score in the last match this Madrid has done. And if you're specific fan of of a player of a Madrid, then you're going to pay attention. Okay, this player has made this score, this player has made this score. So this is how you pay attention to the relevant information. Same here. This attention mechanism got the inspiration from the humans level attention. They pay attention what you're trying to say. Okay, I have to pay attention to in fixing the code. Okay, this is my first attention level. Where is the error? Now second job is to find out the error. Then third job is how to fix that error, and so on and so on. Whatever the number of levels of layers of attention I have to pay, it goes and find out the place where I have to pay the attention. So it goes in a hierarchy. First, what I have to do, what my user is trying to achieve, I have to achieve that as well. Okay, how to achieve that? What's wrong? I have to fix that. I'm having error in the line 9. Okay, let's go into the line 9. Okay, this is the error I'm trying to solve here. So this is how the attention mechanism works. Like how attention mechanism work in AI system, assigning importance to words. So just like you enter a code which is having an error, it's going to importance make an the weightage of that prompt, the weightage of that word in your prompt will be high as compared to the other word. Unlike traditional model, AI does not process all words equally. So it's not going to process all the words equally. That error word will be processed, will be having the high weightage. It assign attention weights to focus on important words. So it's going to focus on the important words when generating the input, when generating the responses. Example, AI translation using attention. Input sequence is the weather is great in Paris today. So what I am going to translate is I am going to focus on which keywords I have in my input prompt. So my AI system is going to focus on weather and Paris when translating into another language. So less important words receive lower weights but still contribute to the context. So the is these kind of words won't be match that much important, but still it will be playing a role in my country in my context contribution. Self attention in transformers. So this all mechanism is called as self attention, which gives the capability to your model to process the bigger text and only pays attention to that part where I have to work on. Or AI compares each word in every with every word in a sentence. So each word will be compared, every word in a sentence captures the relationships. Obviously, I have to capture the relationship. Let's say I'm talking about the bank. Am I talking about the river bank? Am I talking about a financial bank? So this contextual relationship should be is also very important. So that's why the each word will be compared with the other word. So to get the more contextual understanding. So just like GPT is also a very context aware model, it has the capability to understand what you are trying to explain to the model. Any other large language model, they are very good in understanding the contextual so this is how we have explored the attention mechanisms and the transformers are work together. So if you guys are trying to solve any problem and you're trying to create any EA system, you should keep in mind is this model is going to be self attention based, multi-head attention based, and cross attention based. So based on this, you can easily derive this solution which can pay attention to your problem statement which you are trying to explain through your human input text. And after this, it can also generate what you are trying to achieve. So that's it for today. If you guys have any question, I know it was a quite theoretical part, but if you guys have any question, I would love to answer your questions. Yes, Caesar, what's your question? You can unmute yourself.
In the beginning, we were discussing about the limitations and the difficulties someone may face when developing their own large language model, in which you mentioned the lack of computational resources. So, sir, what about using Google Colab? Like, we can use it to as well to overcome that limit. This is my first question, and second question is in developing, as if we want to develop a generative AI model in Pakistan and train it on Pakistani data, because since Pakistan does not have that much data, so it will be a bit won't it be a bit easier to train that? At second and third of all, what is the roadmap of developing such a generative model? Thank you, sir.
Okay. Rajat, all three questions are really good. Really good. First is obviously Google Colab is available. They allows you some free resources till certain extent. If you're trying to train a model, Google Colab, before 4 p.m., you can easily do this. But after 4 p.m., the Google Colab get lot of you can say traffic. You won't be getting that free resources. So you can use Google Colab. But for the fine tuning, maybe it will crash your environment because it's not they are not really you can say contributing towards the Gen AI models fine tuning. Till deep learning, you can go with it. And second, yes, the data set is not that much available. If you even you try to gather the data set, you won't have that much information available. You can all the feed raw information and may that not work very well for that problem statement. And the last one is the roadmap for. Can you just repeat the last question? The roadmap for your large
The
language.
roadmap for developing such a generative model in Pakistan.
Okay, okay. So first, obviously, you need a very large amount of data set. It doesn't matter is it structured or unstructured. These Gen AI models can easily process the unstructured data as well as I mentioned earlier in the start of this session. Once you have this data set, then you will have to do certain pre-processing things. Then first you have to identify what you are trying to achieve. You are trying to create any you can say GPT based model, just like we have a GPT. GPT has the information about over the internet, or you're trying to solve a problem. Let's say you're going to solve a problem statement, then you have to prepare the data set. Let's say you're trying to solve a problem statement of classification, then you have to pass the data set. Uh, then you have to pass the data set in that manner so it can see my training data set and the label as well. So this should be your, you can say, roadmap. So first prepare the data set and see which problem you're trying to solve. Yes, fine tuning is possible in BERT and it doesn't take much time. You can train your model in, you can say, 9 to 8 hours if you have even normal resources. Are there certain keywords are predefined for attention? Are there certain keywords are predefined? Certain keywords? I didn't get it, Monica. What is meant by certain keywords are predefined? Uh, for attention mechanism, let me attention weightage. Let me give you attention weightage is totally subjective to the problem which you're trying to solve. If you guys have used a chat GPT, you can now easily relate. My first task from ChatGPT is to write an email to my boss. So my ChatGPT will understand, okay, I have to talk to my boss in my email. So dear boss, this will be my this is whatever I'm trying to say. So my attention weightage is totally towards the boss word. All the email is related to the boss, which is whatever the question, whatever the message I'm trying to uh, you can say give him. And second is, okay, I'm writing a blog related to the machine learning. Can you please write a blog on 1,000 words? So my second prompt was writing a blog that is around 1,000 words, and I have to publish on my website. So it will start generating a blog for me. The ChatGPT will start generating a blog for me that will be related to the machine learning in 1,000 words. So attention weightage is totally subjective to the prompt which you are trying to give your model, and that is calculated based on your prompt. Some context to examples of system that uses encoder. Yes, classification algorithms. Those classification algorithms, uh, all the classification algorithms use the encoder part only. Encoder is just to whatever the input you are trying to give your model is just to encode into another language, into the language of computers, into the language of models.